Hey everybody, I'm Alex. I'm here joined with Lee, our resident architect for all things Planner for the Semantic Kernel. And we're going to walk through the latest iteration of it, a stepwise planner that just got landed into the C# side of the Semantic Kernel. So let me share what the PR looks like. And Lee, do you want to talk through what we see here?
Sure. So this is Stepwise Planner. For those that are familiar, it implements a miracle system, MRKL, which stands for Modular Reasoning, Knowledge, and Learning, if I recall correctly. There's a link to the paper that it's based on in the code for the Stepwise Planner. And this was actually a community contribution from Kaza. You can see there pull request 992, and so we took that and really appreciate their contribution to get this going. In short, this is different than our current planners. Our current planners, Action Planner, kind of implements the intent detection pattern. Given a goal or an ask from a user, what's the one single function that's registered in my kernel that's most likely to satisfy that goal? Sequential planner is the next step beyond that. Given a goal or ask, use multiple functions and chain their outputs amongst each other as appropriate to accomplish a goal. Sometimes that's also referred to as a plan and execute type of a system. You get the plan up front, you can see what it is, you can review it, you can change parameters maybe as needed, tweak things, and then execute that plan. So one of the benefits there is being able to have that visibility into exactly what's going to happen. This stepwise planner is a little different in that it will take a goal similar to the other ones, and then it'll loop through and create a chain of thought, actions, and observations. So typically the first thought will be whatever it needs to do to accomplish the goal or ask that it was given. And then it will propose an action, which is just calling one of the available functions. The result of that will be given back to the LLM as a observation, and it will take its next step from there. Either calling a new function, maybe it needs to correct itself based on the output of the previous function. And that will loop as long as it needs to find a final answer. Obviously, you can configure it, with a max iteration limit, so it doesn't go on forever. Yeah, I think that's about it for now. So you can see here, initializing my stepwise planner, I'm giving it a kernel instance that I've imported a web search skill and an advanced calculator skill and a time skill. The web engine skill is powered by a Bing connector, and let's see, there's a configuration object. There's this one particular skill I definitely don't want it to use, so I've added it to the excluded functions. There's a configure parameter for min iteration time in milliseconds. This is basically to just make sure the planner doesn't go too fast, too hard. Especially with some of the chat models, some of these thresholds that like GPT-4, at least in the ones that we have available, are 10,000 token limits compared to things like GPT-4 32K or GPT-3.5 Turbo, which has 120,000 tokens per minute. This can be a real problem. So this is just kind of a amount of time to pause between each step. So create my planner object. I give it my question, tell it to create a plan. And this plan, I'll show you, unlike the other planners, the plan it gives is actually static. It's not created by the LLM. It's a static plan. You can see here creating a plan object, and it's pointing it to a single function, which is the execute plan step. Set some parameters, say that it needs function descriptions, it needs a question, and then we also define some outputs of this plan. So we're going to give you back a scratch pad, we're going to give you step counts, some skill counts, and the details of the actual steps that were taken. In the future, it'd probably be, we would like to advance this in the future to actually make this a plan object itself. And I think it'd be really useful to be able to take this plan object, reduce it to the minimum number of steps it needs to take, because I'll show you in an example here. that it's able to make mistakes, learn from it, and correct itself. So if we could reduce those plans into the min number of correct steps, we can then save that plan and reference that plan as a function in the future, including by planners. And so create that plan, we have the step, and we return that plan. And so just like any other plan, we can then say invoke async. We can give it a context, which in this case is not populated with anything. And you can see here I'm getting out details like the skill count and the step count when it's done with execution. And so these are some of the examples we have in this sample. Who's the current president of the United States? Something that traditionally LLM will not have access to because it doesn't know what today is. And what is their current age divided by 2? Our bias is showing a little bit. And if I scroll down, you can see running against text completion, it's able to get the result. Current president is Joe Biden. Current age divided by 2 is 40. You can see it took 10 steps to figure this out. 2 of them being search calls, 1 of them being a call to our date function in the time skill, and 1 call to our calculator skill. And this also runs against chat completion endpoints, and you can see it has a very similar answer with a similar number of skills executed. And do you have any questions before I continue, Alex?
I do. Is there a way, or does it expose like a drill down of like the parameters for the web search skill or like all these other skills that are being used?
Yes. Yes, you can see that in the steps taken that is returned. So let's try that actually. Let's do a live demo. Let's just do text for now. Let's go to here. And yeah, again, this is just going to be kind of a JSON serialization of an object that's kind of specific to the Stepwise Planner. It'd be really nice if we could improve that to make it an actual plan object, so it's something that folks are already used to using. But you'll at least have the insight here into what's going on. While that starts to run, I'll just kind of give a preview of some of the other questions, right? So trying to get a little more advanced, look up some famous person's girlfriend, what is their age raised to his current age divided by 1 power, right? And you can see it's able to figure out who their girlfriend is. This is actually inaccurate because it changes often. So this is really just based on what the results of the Bing search is.
Sure.
Sometimes you'll see this run and you'll see it find this at first, and then while it's doing other searches for more information, it'll find, oh, as of this date, Leonardo DiCaprio has a different girlfriend, and it'll correct itself, which is really cool to see. There's concepts of grounding and kind of doing that kind of validation, which needs to be integrated here. If you include those skills, you should have some success. Okay, cool. This is running. So let's see what's going to happen. Actually, it'll probably take a minute. Let me go into these next examples because I enjoy them.
Can we talk a little bit about the correcting piece, or like how does it correct itself? How does it know to correct itself?
Yeah. Let me get into that here. Apologies. So let me focus on that first, actually, before I run the demo. This is an output of a previous run. And so you can see this is the ask. You can see right away it has a thought to answer this question. I need to find out 2 pieces of information, the name of the current president and their age. Then I need to divide his age by 2 and round the result to the nearest integer. So you can see here's that web search. You can see the parameters here. So this is what you would see in that serialization that I was about to show you. And then this observation here, this is the result, the output of running this action. So I give this observation, the planner gives this observation back to the LLM and says, okay, do it again. Gives us a thought. You can see here, basically, it's just kind of parsing this output. And you can see here, it actually kind of fails. It doesn't give us an action to take. And then I do it again, and it doesn't give me a thought. It doesn't give me an action to take. It's kind of stuck, actually. Finally, it gives me a thought. You can see the possible continuation because this is a GPT 3.5, I believe, which is kind of frustrating. And again, it doesn't give us an action to take. Eventually, though, it gets it gets up to speed. It's able to synthesize the result from above. You can see the thought. The observation confirms it's Joe Biden. Need to find his current age. I can use the time.today function to get the current date, and it already seems to know his birthday. So I don't believe it got that from search. Typically it would. So you can see that it says, okay, call time to today action. It gets observation. Cool. Observation shows current date of June 26th. Calculate his age. No action to take. Kind of a bummer. But you can see eventually here, okay, cool. His age is 80 divided by 2. I want it to be the nearest integer, so I'm going to use the round function, which is available in my advanced calculator, and you can see it calls it here. However, when it calls that function, advanced calculator.calculator, it gets an exception. And you can see it could not evaluate round 80 over 2. And you can see round takes exactly 2 arguments. So, right, this is something, part of this calculator skill. It doesn't expose these details as part of its manual. So it's learning this on the fly. So you can see the next thought is, oh, there was an error in the action, requires 2 arguments. And here it was able to correct itself, call the function correctly. And get the correct answer. It's pretty funny because it's kind of a simple example. I've seen other instances where it sees this error and it tries over and over again. And eventually it's like, round 80 over 20 should be giving me to 40, but it keeps erroring. And so sometimes, it's quirky like that and can get stuck. Yeah. So that's that example there. Any other questions? I think that covers the other part, so I'm not going to debug it right now.
No, that's very cool because in a traditional program, the moment you run into an error like this, it would just like cut out, right? It would just stop. But in this case, it's able to recover from that.
Yep.
Adjust the inputs to this function.
Yeah.
And ultimately, complete it.
That's right. That's right. And yeah, here I'll go back to these other examples just to show that it's pretty complex, right? What is the capital of France? Who's the city's current mayor? What percentage of their life has been in the 21st century as of today? And you can see, it took 40 seconds, 7 steps to figure all those things out. It took a couple of web searches and a calculator, and this is an accurate answer. And then again, what is the current day of the calendar year? Using that as an angle in degrees, what is the area of the unit circle with that angle? And again, it's able to figure these things out. You can see this one surprisingly took 16 steps. I'm not exactly sure where it got stuck there. And you can see, here it's calling a lot of different functions. Some of these functions probably are not being called properly, or just chose to do it all rather than just use now. So
yeah.
Going through those steps taken and analyzing it would be a good exercise. So,
have you observed that if you go from a, let's say, 3.5 turbo model to GPT-4, does it reduce the number of steps taken?
I haven't done enough of an analysis to say for sure. Other than I can say it fluctuates. It definitely can fluctuate. Especially when things are based off search, right? As soon as those results you get from search are different, the semantics of the other functions that execute can be wildly different. Yeah. I'm pretty pleased with GPT 3.5 overall, though. I will say that. With other planners, I've been sticking to GPT-4 and GPT-4 32K. This one I've tried to stick with GPT 3.5 Turbo, and that's what all of these results are with. So I'm pretty pleased with that.
Yeah, I feel like in contrast to the previous planners, really my thought is that the big unlock here is the ability to correct itself. Like if you let even the 3.5 turbo model just try to repeatedly solve the problem. You see people doing this with ChatGPT, the platform, right? They have it spit out some code. People try running that code, they get an error message. They literally paste that error message back into the platform, and it's able to output corrected code.
Yep. I agree. And I've been talking with some folks actually who were, trying to use Sequential Planner before. They still want to use Sequential Planner because they like the ability to show the user what it's going to do before they do it. You can do that here, right? You would just need to do it for every step, right? And you'd be like, I'm going to do this. I want to do this. maybe you could gate that a little bit more on destructive actions, right? Before, if it's just querying the web or just calling these time skills, like that's fine. The user probably doesn't care, but as soon as it's going to call, drop table, the user definitely wants to know that. But one of the things that I think would be fun to experiment with, I would like to do it whenever I get back around to having time, is combining these planners, right? If you use a sequential planner, create a plan, execute it, or have some sort of evaluation method to see if it's a valid plan, and then be able to say, nope, you did it wrong, or nope, this isn't going to execute, and give that back to Stepwise Planner, then Stepwise Planner could probably try again to create a better sequential plan.
Mm.
I think that could be really neat. Um, a couple other things I want to call out here is that we've made some improvements to sequential planner, uh, namely in the reliability of it to say when it can't return a plan. And right now we actually have a PR out that I'm hoping will go in very soon that enables two things. One is custom manual discovery. So today the functions that are used are based on whatever's imported into your kernel instance. Um, we're changing that so that way you can override supply a callback for getting available functions. And so say you have a list that you've maintained in a memory store and you don't want to import all of those functions into your kernel because your planner may not need them and that would just be a waste. You can have your own logic here to let the planner know what you want to be available. And then when it comes to function execution, you can also override the loading of those functions, basically, right? If it's not available in the kernel at the time, then you could do the work to, import a ChatGPT plugin that you have capabilities of using. Um, Additionally, we updated the sequential planner prompt to no longer have these examples in creating a plan. And like the Stepwise Planner, have really focused on the details of one, creating a plan, what that looks like. You can also see we're starting to add the reason here. I mean, this is all we had to do, and we get the reasoning for all the steps here. So we'd like to add that to the plan object model as well. But yes, defining the instructions for calling plan, and again, really just being clear on the instructions for calling a function, giving it trivial examples of do's and don'ts, really has helped reduce GPT 3.5's tendency to hallucinate or use these example functions. It was just really difficult to get it to stop doing that. So we've cut them, we've removed them, and I'm having great results with this. So I'm hopeful that others will as well. Um, yeah, yeah, that's that.
That's very cool. No, it's definitely something I want to try myself
Yeah,
with that. I know this is in C# today, soon to
yes,
be in Python as well,
yes.
and the other languages that Semantic Kernel will support. Um, but very cool, very very awesome. Um,
Yeah,
I
there's
guess.
one other
Oh yes.
one other change I do want to call out too. We've added methods to import plans into the kernel. So if you have a plan, you can register that as a function in the kernel. And then if you use Planner, theoretically, I haven't actually done a whole lot of testing there, but theoretically, the planner should then be able to use those plans as steps. And I think that will unlock a lot of cool scenarios. So I'm hopeful people will play with that.
Very cool. Very cool. All right. Well, as we wrap up here, Lee, since I know you're heading on vacation, is there any uh, kernels of wisdom that you want to pass to the semantic kernel community around using Planner, experiments they can try out, things like that?
Um, so hopefully people are already aware, right, that a large part of planning is defining your functions and defining your semantic functions and your native functions. The descriptions used there, the naming for variables is important and will change what the planner is capable of doing. I know a lot of our sample skills. I would like to clean them up. Actually, we have a lot of sample skills where we don't have definitions for parameters, even the default input, and adding those goes a long way. Um, the other thing is there's a couple sample skills for like element at index And there's actually a transform output skill that's kind of in PR right now from the community. But I think we need more of those kind of output parsers for semantic functions. And it's great. It's great that we can kind of do those things semantically, right? Like if you have a brainstorm function that outputs a list of topics, and there's a you don't even have to know how many there are, but say you did know, generate 3 topics during this brainstorm session. Um, Being able to pass that on to another semantic function that can then break that into chunks um, is crucial. Because especially because the templating language, you can't do kind of object expansion. It's just string expansion right now. Those are really important for creating successful plans. Um, and yeah, I encourage folks to play around with Stepwise Planner. Maybe contribute back to the community on ways to use Stepwise Planner during development, and then kind of export what has happened as a plan object that can be used in the future. Because I feel like teams are going to start, you know, using Action Planner as kind of the first step for like deciding which fork a user message or intent to go down. Makes a lot of sense. And one of those skills, right, could be call sequential planner, could be call stepwise planner, call into a memory store to find plans that I've run in the past that accomplish the same goal already. Um, Doing that automatically, right? Like running stepwise planner, your user executes a plan and they're happy with the result. Taking that plan, registering it with the kernel. Um, yeah, I want to see people do that and see how well it works. I think it will be really fun. So I think that's it. I think that's it for now.
Very, very good. Very good. If anything, that's a lot for the people to work with. So,
Yeah, yeah. I
well, Lee,
encourage everyone. I
yeah,
appreciate everybody's feedback. File issues, please let us know how we can make these things work better. So
for sure, for sure. Well, Lee, thank you so much for the time.
yeah,
Really appreciate it,
thanks,
and
Alex.
have a great vacation.
Yeah, I will.
Well
Cheers.
deserved. All right, take care.
Bye.